So what we will do is little kind of a practice for this is prerequisites to prove difficult identities. If you see on the packet, there are a lot of difficult means like confusing identities. But to make that easy, let's brush up this easy one to get used to what is sine, cosine, and the chart. What are the formula? Oh, there. Please keep this right like this in case you need it. So the main thing is those students who missed, Natalia and Bianca, this is what I did. Remember, the main formulas are reciprocal identities. That cosecant is 1 over sine, secant is 1 over cosine. Right? So these are the two main ones. Then if there is an angle negative, we have not done yet, we will see that. Only for cosine, the minus vanishes, the rest you have to take out the minus outside. Then also we have this important identity, sine 90 minus theta is cosine. They complement each other. If it is sine, then it is cos. If it is cos, it is sine. That's all that means. Secant and cosecant, they go together, and tan and cotangent. These are the ones we focus more on Friday. Sine square plus cos square is 1. 1 plus tan square is secant square. And 1 plus cot square is cosecant square. And then each one has a 3 separate. Nobody's listening. Okay. 1 minus sine square is cosine square. Or 1 minus cosine square is sine square. And from 1 plus tan square, you can also remember secant square minus 1. It depends on which one you're talking about. If you want to write tan square in terms of secant, it will be this secant square minus 1. Or you can directly write this secant square minus tan square. Secant square minus tan square is 1. Or cosecant square minus cot square is 1, like that. I have not written down this, but I should have written down here. Let's write that part also, which we missed here. What I'm saying, there are two over here. One is, if it is secant square is minus 1 is tan square. And also secant square minus tan square is 1 straight away. And the same thing you do here also. Cosecant square minus 1 is, I should have made a separate chart for this, I missed it. And cosecant square minus cotangent square is 1. Basically it means like this, 1 plus 4 is 5, right? So it's same as writing 5 minus 4 is 1, or 1 is, or 5 minus 1 is 4. So it's the same extension of that idea. Okay, let's go directly and let's do this first one. Natalia, help me. First one, quick. At the most, what can we do? That's my goal. I always put this. At the most, what we can do, that's all. If it rains outside, what do we do? At the most, if you have an umbrella, use it. Otherwise, you can't do nothing. You just do wet, or you just go under somewhere where there is, you don't get rain. So what is that we can do quickly? Let's write one step. Instead of in place of, can we change cosine? Cosine is cosine. You can't do nothing about it. But at least do we have a formula for what is tan x can be written in terms of sine and cos? What is that? There you go. So let me use. So this tangent, let's replace it by sine, thank you, over cosine x, correct? So you already know that, and you can do mentally, you know the answer. So that's what I want you to do. Eventually the goal of this is, oh Rebecca, why do you have to write all this? Can't we do it mentally? Yes, you can do mentally. And this is cosine of x, correct? Now cosine of x means it is divided by 1. That you don't have to, but just. So next question is, at the most, what can we do? What I would like to show is, we can just cross out. See this cosine, just cross it out. But I'll write just one more statement to write. Okay, this sine x, I'll keep it right here. And this cosine stays the same, and this cosine, I'll put it right here. Just to show, you can all use the commutative property. Is cosine x times 1 is same as 1 times cosine of x. So you skip this step. We don't need this step, but I'm just writing, just to get a conceptual understanding. And this cosine divided by cosine is 1, right? Agree? Cosine x divided by cosine x is 1. So one is you replace tan by sine over cos, then I write this rearrange. As I said, you don't need this steps. I'm just writing, still I'm writing that. You could just say, okay, let's cross this out. I go, see? And then what do you get left is the sine of x over 1, which is, and done. So that's the most, at the most what we can do. Are you comfortable now? As I said, the goal is to get comfortable with all the sine, cos, all the time. Go to the next one. What at the most what? Jocelyn, tell me, quick. How can we write cotangent? So, is it sine over cos or cos over sine? Yes, very good. So replace this by cosine over sine of x. Okay, and then we can replace tan x, sine x over cosine, right? And there you go. You can just cross it out and you know the answer. But I will go one step ahead to show that this is cosine of x, and this. So the black remains the same place. I mean, this sine x, but this sine x, I'm going to write it right here. Is that okay? You already know the answer is 1, correct? Skip, you don't need this step, but I'm writing that step just to show we can cross out right here. See, done. Just 1 is remaining. So basically, it's like 1 over 1 times 1 over 1, and it is 1. Done. So simple. Should we go to the next one? Secant of what is that secant by reciprocal identities? And right here on the chart, what does secant means? 1 over cosine. Okay. So that's all you do. So replace. Am I going fast? No. Are you sure? Yeah. Okay. So secant, how can we write? 1 over. So this secant, I'll put a color coding to just to show it is 1 over. Okay. Now you may get a little confused suddenly. Oh my God, that's pi by 2 minus x. Remember this pi by 2 is 90, right? It's like you have a triangle. Just in case we forget, remember this. If this is theta, that's 90, and that's the opposite. So think of if this is the angle. How much is this angle? I'm just recalling this. You remember? If this is theta, what is that? Good question. If this is 20, if this is 20 degrees, how much is that one is? 70, correct? Yes or no? Yes. I'm just showing sometimes it's needed to understand the concept. If I write 30, what is the other one?
60.
How did you get 60?
Because the whole triangle side equals 180.
Yeah, the whole triangle is 180, right? This is already 90 degrees. This is already 90, right? So these two angles have to be 90 also, agree? Okay. So if this is 30, what is that one becomes 60 because you just subtract 30 from 90, agree? You just subtract 30 from 90. So that means if I put a variable, forget the 30, if it was a variable theta, then how will you write that other one in?
Theta minus 90.
Is it theta minus 90 or 90 minus theta? 90 minus. So let's write that. That is my blue. Okay, I have a blue one. So this is 90 minus theta, correct? So now watch this. If I want to write sine theta, what's the sine of the theta? And we know the definition is opposite over hypotenuse. Agree? Yes or no? So what's the opposite for this one here? So across, can you see this? So opposite over. So let's call them as A. I'll call this as, this is C, A, B. Sorry. So yeah, this is B and this is small c. Got it? So even though you should have been known this directly, I thought of showing this. Oh, let's see what is the opposite for this. What's the opposite for orange color? Can you tell me?
B.
B over,
Oh, C.
agree, right?
Mhm.
Or let's put a number. That's better to just to avoid it. This is, let's put this as, I'll put this as, let's put this as 3 and let's put it 4 and that is 5, because we all know that it's a Pythagorean triplet, right? 3, 4, 5. 3 square plus 4 square is 5 square, right? Natalie, are you there with me? Your glasses missing? Oh, you look beautiful today, is it?
I can't see.
You can't see? Oh God.
You can look at my phone.
You want to come closer or something?
Or take pictures.
Okay, so let's write the numbers. Can you help me quickly? What should I write here?
3.
3 over 5.
Agree? And if I ask you, what is cosine of 90 minus theta? That one, this is the blue color. So let me take this off and write down this as 90. Now the angle is this one, right?
6 over 4.
Yeah.
No, what is the definition of cosine means?
Cosec?
Adjacent over
Hypotenuse.
hypotenuse, right? So this is adjacent over
Oh,
hypotenuse.
that's a 4.
Now you need to be very careful. Yeah, this is 4. You need to be careful now. This, for this angle, that's the opposite and that's the hypotenuse, right? Nobody's saying it. But now the reference, the main angle is the blue one. If that's the blue, that's the opposite, correct? That's the, and this is the hypotenuse. Now can you tell me what is the answer?
3 over 5.
Oh, shit, that's true.
Correct?
Yeah.
Wait, both are 3 over 5, right? So what did you learn from this actually? Can you see?
Oh, that's the same.
It's the same thing, like that means the sine theta, it means what this means is, it's like can you take a note in your notebook, write down this? Cosine 90 minus theta is sine theta, that's all you learn. It's like if you have, they complement each other. If it is cosine 90 minus theta, you could also write this as, if this was sine 90 minus theta, what is the answer will be, can you tell me?
Is it because they're switched? You switched the angle? And then you
Yes, the angles stay the same. What I did was, which is it's all about what angle are you thinking. The first one I'm thinking of the orange angle. Do you see the orange angle? And I put the orange angle right here. But when you think of this orange angle, and the definition, sine is opposite of a hypotenuse. So you're thinking of, Jocelyn, if this is the angle, that's the opposite. That's the hypotenuse. But if you go up here, the blue one, that's the opposite, that's the adjacent. So because I wanted to prove that, in order to show this, I use cosine here, just to show that, hey, this, if that is 3 over 5, this also is 3 over 5. All it means is the box, cosine 90 minus theta is here. So that's why I say, okay, at that stage you may get confused. As an identity, everybody should just remember directly that, hey, straight away, sine, see, it's right there. So the question was why, right? So why did I, the goal is just to make sure you really get this part. See this part? You see? Sine 90 minus theta. Pi by 2 is just 90 minus. So, we did this, but you forgot. That's why I'm still showing it one more time. We had done this earlier. And the same thing is also here. 10, see? 10 pi by 2 also we can do it. And if it is cosecant, you can always check that. But right now, let's go directly. Can you tell me what should I write now? What is pi by 2 minus x now? What should I write here? Cosine x. So see, I did not wanted you to be robotic and oh, the chart is showing, so let's write cosine. No, but we also should know why and how. What is the reason? That's the main goal. Now you have this means over 1, right? You can just cross out, done. One answer is 1. I'll just write one step ahead and say 1 times cosine x is cosine x, cosine x is 1. Let's go to the next one. Can you quickly do it yourself? Finished? How many of you did thumbs up? We can do mentally also, right? The goal is, remember, at the end, as we progress, I want you to mentally do. Can you do mentally? That's the goal. Without even writing any step, we can just think in our mind, and the formulas are right there, and can we use those formulas? So this is just a brush up for the main ones. How many of you got one answer? All of you got one? Correct, right? So we all know that it's the same thing, like where something like this. It's the same thing. Instead of tan, they give you cotangent. So replace cotangent as cosine of x divided by sine. So it's better to write to get used to this.
Oh, and sine doesn't change into anything?
Because sine is like the basic fundamentals. Like sine and cos, you can't do nothing. So as more is better always to change to sine and cos. Anything is there. Except sometimes see this part there is a okay. Let's finish this. So you got okay. No, the answer is not 1. The answer is what? Cosine. Yeah, I'm sorry. I was thinking something else. Yeah. What about this part? So there are 2 ways you can do. See. 1 plus tan square cosecant square is, anything strikes you here about? Of course you can do, you will say, Rebello, why did you write this way? Watch these steps, okay? Tan square, tan is sine over cos, right? Agree? So because there's a square, you have to write like this, sine square over, right? And then the down one, cosecant is, from the chart you see, is a reciprocal identity is 1 over sine, so it becomes sine square. And then,
Is it also?
It's always cos.
say it again.
So it equals cos.
Sine. Which one? Cosecant. Cosecant is the reciprocal identity. Cosecant is 1 over sine.
I was looking at the bottom.
Yeah. But the thing is, we can do this. Okay, I'm not saying you can't do this, but I want you to think of the other trigonometric identity. What is 1 plus tan square? Do you see this 1 plus tan square? Yeah, so that I'm not saying this is wrong. You could do this way and then multiply. You want to get the same denominator, so cosine square, and you would multiply up down by that. And there's few steps there to do. So ask me. Yeah, we are on this one now. This is done. This is cosine. This is done. You can't do anything there. Okay, what is 1 plus tan square? Let's replace directly now. 1 plus tan square can be replaced by?
Sex squared.
Yeah, sec square, right? Or it says secant square theta of the x. The 1 is. Now the question is why? Now you have only, there is no 1 plus at all, so it's just one thing, right? Just a secant square, and this is cosecant square. But we do know what is. So I'm gonna write, this is the main division line, so main division line, division. But then each one will be a separate fraction, right? What I'm saying is, okay, first of all, what is secant? If this wasn't there, what would you write? What is secant means?
Whatever it comes.
So let's write it. So 1 over cosine, right? But, what was there? There was a 2, right? It's like secant is multiplied itself twice. So if that's the case, then you have to put a 2 here or this. Cosine. So far so good? Then down will be, what about cosecant? 1, okay, for that I will use, I have a great marker. Okay. So this is 1 over. Do you agree? Now you just next step what you do. This is what you guys are always been doing. Keep, change, flip. What does that mean? So the main thing is the numerator and the denominator. Remember, this is the numerator, right? Nobody say yes. This is the denominator. So when you say keep, change, flip, means you keep the numerator as it is, change the division line to multiplication, and then reciprocal of the denominator. So this is how. So actual way is, if it is AB divided by C over D, it's keep the numerator A over B times change to, and C over D is D over C. Look at this formula which you know from 7th, 6th grade, but we forget, but still I'm writing. So let's write. So this becomes equal, keep the orange color stays the same, 1 over, is that okay? So the goal is to get used to this sine, cos, tan, everything, okay, constantly. So when you go to college, maybe some of you will be taking class, I want you to get really be a, what do they call it, smooth transition to our college. So this times, so pink, what happened to the orange? It flips, right? The sine square goes up and then goes the 1, correct? And this is same as sine square divided by cosine square. Should we keep it or can we write? You can keep it, but can we write it in terms of something different ratio? What is sine over cos means? 10. So we'll use 10. Okay? So we'll change this. So the question is simplified. They did not tell us to write it. If they had to ask, prove that this is same as, they could have asked us to prove that. But they didn't ask. So it's just reduced to the, that's the lowest possible form, which you can also write it as 10 square of x. Is that okay? Any question? So let's get back another more now over there. And I'll just take this. Okay, who wants to answer the first one? 6, problem number 6. Check the chart. Such nice job I did. Who is going to help me with the formula? 1 minus cosine square. What do I replace? Yeah. Yes, look at this. What? 1 minus cosine square, right here? So your question would be, why do we change this? You could have said, why are writing in terms of sine square, right? And the goal is, you see the denominator, there is a sign there. So we'll try to replace this numerator can be replaced by, nobody's telling me. Yes, that's sine square theta, correct? It only means there are 2 of them. So even though you don't see them, what that means basically, it is sine theta times sine theta is twice. Can you see? You know the orange color is that it's like 2 multiply itself 2 times.
But,
yeah. So I just want to make sure you get that part. We skip it. We don't write like this. Okay? Even though, remember when you write sine square, what it means is you multiply itself twice. Right, people? So this is sine theta, sine theta. So instead of doing, look at this, instead of crossing, this is right way to do. Okay, this is right way to do. But what we do, we just cross this one and one of this. Then we're done. See how it is cancelled? So we don't show this step, but we just, that's it. Nobody said yes. Agree, right? It's like, what's this? What's this step? If I had to write a squared divided by a, the answer is a. Do you agree? Nobody said, check this out. So, what, back of your mind, you are saying there are two A's, right? So basically it is A times A divided by A. One of them goes away, so one stays, right? But we don't show this step. We say, hey, just cross this out. Hey, there you go. So that's how we do and say, hey, let's not write that. And we say, okay, this equals. Everybody okay? Understood, right? Let's go to the next one. Let's go a little faster now. What do you see here? Can you make it more smaller? Can you factorize? Can you pull out? Undo distributive property. How many cosines are here? How many are here? So one of them, can you pull it out? Now the question is, you may say, what is that pull it out mean? Watch this simple example. If there was a square and there was, if this was the case and I ask you, hey, factorize, what does factorize means? So how many A's are here? There's one. So we can pull out one of the A and then write it what? Correct? So now if you get confused, just check it out whether did you do the right thing, and you can just multiply it. What is A times A? A square, right? Or what is A times minus 1? A times minus 1 is? It's not the same thing? It's just in undo. It's called undo distributive property. This is distributive property, but this is undo. Now the question is, can we extend this idea to the trigonometric ratio? So how should I write it? Back to Hugo. Tell me quickly.
Cos
Okay.
x
Okay.
parentheses
Parenthesis.
cos what is. Oh no wait. So
Now be careful. This is opposite, right?
Yeah, so it'd be 1.
So this cosine x is a single one, right? It's just a single one.
Yeah.
So basically, even though it's like 1 multiplied times, something like that it is. So you just take cosine x. So what stays? What stays is like a 1, correct? Agree? Yes or no?
Yes.
And minus. So this base, there were 2 of this, right? How many of this? There were 2 cosine. One of them is taken out, and one of them will be left. Okay, that's all it is. And we can't do anything here else because that's it. That's the end. We can't do nothing about it. And they did not ask us also what are we supposed to do. They didn't show that. What about here? Anything strikes you? So let's separate this. Yeah, I'm just making a kind of a. This looks so stupid. So much stuff is there. But if something strikes you, like combining 2 of them,
Combine.
do you see sine square and there is also cosine square? There's a plus. Who said that? That equals 1. Do you see that? So sine square plus cosine square gives you what? So it's like we'll try to put this one and this one, put it together. Let's write down. So we can write one step sine square of x plus cosine square of x. I'm putting the orange color to show, and the tan square stays the same. Divide by secant. Is that okay so far? Now you could have skipped this step also. You just because you know sine square plus cosine square is 1, and just write 1 plus. That's it. There was no need to write this step, but I'm still writing. Why am I writing this, Bianca?
Because we need to know it. We need to know why and how.
Yeah, and actually you're using commutative properties. See, there's a property that is commutative property. What is commutative property? Property of addition. It means if I have a plus b is same as b plus a, you just have to replace. This comes here, that's it. Am I right? So you're like writing a plus b is same as b plus a. Now, what is this answer? 1 plus over this secant x, right?
Yeah, and then.
And what is 1 plus tan square from another formula? If you see the chart, what is 1 plus tan square is? So the goal of this is, all this we are doing, why? Just to get used to this. So that, just like that you should get the answers. So 1 plus 10 square stays the same, but the denominator, oh sorry, one MB. So 1 plus 10, I'm hungry. Usually I go and eat when you do work. So this is secant, agree?
X over
And then secant x, that's a single
secant.
secant. So, and there are, the top one, there are two of them, the bottom there is one, so what do we do? Can we just like that? There is single secant x, there are two of them, so one of them goes the same.
Yeah, so it's secant X.
So the single secant is remaining and you just write secant of it. Finish. Let's go directly here. Last three and we are done with this. You can always share, I will share this video, what I'm making in the group. I made one, remember last time, I think I made a video of problem number 4 and 5. And on my YouTube channel, a lot of students are watching from this. I don't even know who others, but it went to 200 almost. I said, what? So people are watching this, and I was very happy that there are some who are watching what I'm trying to show. Because of the color coding, some like this. Okay, we see how it works. Okay, can you try it yourself without my help? Whenever you think of pi by 2, think of husband-wife. See the pi by 2 minus x, this is like, oh, those are the ones right here. Sine and cosine are husband-wife. Tan and cotangent is husband-wife. Secant, cosecant also they are husband. Then we just have to flip, change. Like what I should write in this example instead of this.
Cotangent.
Yeah. Can I make a room for, because I know I won't have enough room there to write. So let me write this on top because we may need more stuff. So this question I write here. Tan of pi by 2 minus x and cosecant of x divided by cosecant of square. Oh, let's see. Okay. So at the most, what will we replace this by?
Cotangent.
Yeah, this one will change it to cotangent of x. Agree? Can you see this? So if it is tan of 90 minus, remember this, don't think too much. What is this pi by 2 basically means? 90 degrees. So tan we can write it as cotangent of x. Is it okay? The cosec, let's keep it cosecant as it is. So right now, let's keep it as it is. Oh, can you cross out right there?
Yes.
I didn't even realize that. Because I did not even check these problems to separately, actually it's always better to first see what's going on. So this cosecant is a single one, finished? And what is left is cosecant of x, agree? At the most, what can we do next? There is no sine and cos, can we get sine and cos? How do we get that? What is cotangent means? Cosine over sine. So let's replace this cotangent as cosine. And cosecant is 1 over sine. Right? 1 over. Okay, here it is. And this put it right there. Now, anything else? Okay, I'm talking, actually keep change flip. There is another shortcut trick, remember this. The shortcut trick is like this. Okay? If you have A over B, C, and there is a B over C, can you see? Do you see the C is divided for both? This is only in such case, there is a shortcut trick. You don't have to don't do keep change flip. Just, and what is left over? Do you see that? Do you see the shortcut? Of course, keep change flip is important, but sometimes if you can see that, just there you go. This sin x. The right way to do is write the orange color cosine of x over sine of x, and flip this numerator stays the same. Flip the denominator. This one becomes sine. Is that okay? So basically, you just cross out this way. And you could have done it right here also, see? And you already got the answer. Right, Natalia? Are you getting comfortable with this? So as you go on doing, then you get a hang of this. Oh, this is cool. Let me spend time at home instead of watching TV. Let me do this. You feel like that way, when I was a student, that's what was happening. Students were playing, and I wanted to play more with this. And I used to just love doing that. Okay, so did you get the shortcut trick?
Yes.
Why are you smiling? See, if you like something, if you start liking something, then you just, that's your priority. Okay, let's take these last two. What about this? Can you help me? What can we do here? Sine over cos.
Yeah.
Change tan to sine cos. And what about this one? Cos over. Of course, the formula doesn't show you. Basically, I think I should have written down here. Remember, I'll just write here. Tan is sine over cosine, and what is cot is? Cotangent is cosine over. Okay, you have to remember that. I did not write it because that's like obvious. You have to know. Tan is sine over cosine, right?
But I was thinking about the Pythagorean identities at the bottom.
Oh, so you are ahead, I think, right? Okay, let's do that. So did you write this as, let me use the color for this. This tan, did you write sine x over cosine of x?
Yeah.
Very good. Then what about the other one? I'll use the green color to show this cotangent. You can write it as cosine over sine. Is that okay? So a lot of stuff there. Now be careful. I'm going to show you one more trick here. So the right way to do is, watch this. There is a 1 here. What does that means? If the denominator is 1, agree? Watch everybody's eyes here. This looks confusing. I'm taking a simple example like this. Do not write this. Just watch. 1. If I have 1 plus 2/3, right? How do we do this? Vidhali? You want to get the same denominator, right? What's the denominator here? 3. Then you multiply 3, divide by 3, agree? And that way you say, okay, that's 3 plus 3 times 1 is 3, so 3 plus 2 over 3, correct? You want to get the same thing. Now what is missing here is there is a cosine, so both places, that means I need to multiply. Watch this. So what do we multiply here? So there is a cosine. You want to get a cosine of x, correct? You can't just write cosine there. You have to also write, there's already 1 here, so I'm just putting a cosine of x. So it is exactly the same thing as this. Can you see this? 3. Is this for us?
Yeah.
Okay. Look, as I said, tomorrow, listen to me. You have that packet, right? You start working on that, open my Google Classroom, I posted a good link, open that, all problems are solved. I really want you to get it. We'll see that. Because tomorrow we don't have class. My question, are you getting this now?
Yes.
Okay, thank you. Not packet, it's 7.1.